Hello and welcome to the second video for section 5.4. In this section, in this video, we're going to be talking about transformations of our tangent and cotangent and cosecant and secant graphs. In section 5.3, I told you that practice makes perfect, and I wasn't lying. Reason being is if you can do transformations for sine and cosine, these new four graphs that we've learned are the same process as long as you remember what the basic graphs were. So first, let's look at the periods of tangent and cotangent graphs. So the functions y is equal to a tangent of kx, let's do this, k x minus b, and y is equal to a cotangent of kx minus b. So we're actually going to do all three. We'll do it in one. So amplitude, period, phase shift for tangent and cotangent. You guys saw the sine, you saw the cosine, so you should be familiar with the labeling. So the rest is just picking out these pieces. Again, k is going to be greater than 0. When we have these functions, absolute value of a is our amplitude. The difference now, though, if you remember before when we were dealing with period for sine and cosine, it was what? It was 2 pi over k. Because the period for sine and cosine was 2 pi. But the period for tangent and cotangent is only pi. So in this case, when we have a generalized form of an equation, the period is now going to just be pi over k. And then our phase shift is still the same idea. It's just b. It's the if I see negative b, it's plus b. If it's plus b, it's minus b. So the biggest thing here, the only thing that's really changed between sine and cosine, if you're comfortable with those, this one should be fine. The only thing that changed on us is the period. Instead of 2 pi over k, it's now just pi over k. Let's look at secant and cosecant. So again, if we deal with amplitude, period, phase shift for the functions, y is equal to a cosecant of k times x minus b, or y is a secant k x minus b, and as all the other ones, k has to be 0. So again, our amplitude is still just as before, absolute value of a. That has not changed. Period. Well, cosecant and secant are related to what? They're related to sine and cosine. What's the period for sine and cosine? 2 pi. So the period change for these equations would be 2 pi over k. Same as sine, same as cosine. And phase shift is just, again, our value of b. So really amongst all this, the biggest change was our period for if we have tangent or cotangent graph that we're dealing with. Other than that, kind of all done the same. So let's look at a quick example. So let's say we want to find the amplitude, period, phase shift for the following. Y is equal to secant of 2x minus pi over 2 and we want to graph, let's change this. Let's change this to secant of 2x plus pi over 2. Get a little difference there for us so we get used to this kind. And graph one period. So you see these are all worded the exact same way. Find the amplitude, period, phase shift of this equation and graph one period. I try to give these examples to you guys the exact way you'll see them worded on the exams, and hopefully the exact way you'll see them worded on the final. That way it's not a surprise to you. Then as soon as you see this problem, you know, oh, this is what I do. Step 1, step 2, step 3, and I'm done. You don't have to worry about what am I supposed to do on this problem. You've done enough of them. All right, so the first thing we have to do when we're dealing with these kind of problems is make sure our x is by itself. So in this case, as with the other examples we've done, we have to factor that out. So we can rewrite this equation as y is equal to, so if I factor a 2 out of this portion, I get secant of 2 times x plus pi over 4. So be careful here. I divide this first part by 2, so I need to divide this second part by 2, which leaves me with pi over 4. Now, the other part of this problem, before we can really get going, is figuring out what is this guy related to. Secant is related to cosine. So when I have my basic graph drawn, it's going to be the cosine graph, but remember secant and cosecant get the asymptotes and then the upside down parabolas to go along with it. So that's what I should have in my mind, what I'm expecting at the end here. So first, amplitude is what? It's just 1. There's nothing in front of my secant function, so I'm not having to change how high or low this thing goes. Period. Well, period, because it's secant, it's related to cosine, it's 2 pi over k. What is my k? Well, it's right here. It's 2. So it's 2 pi over 2, which is just pi. So this tells me that when I do my first row of calculations, the last value I should have is pi if I've done everything right to that point. And then lastly, phase shift, I see plus pi over 4, which means my phase shift is minus pi over 4. So the graph is going to move to the left now. The first two examples we did like this, it was plus, so it was moving it to the right. Now it's going to move it to the left. Methodology still the same. So I know my normal points would have been 0, pi over 2, pi, 3 pi over 2, 2 pi. Step 1, divide by k. That's always my step 1. So in this case, divide by 2. 0 divided by 2, 0. Pi over 2 divided by 2, pi over 4. Pi divided by 2 is just pi over 2. 3 pi over 2 divided by 2 is 3 pi over 4. 2 pi divided by 2 is pi. Hooray! Everything's checking out. This is the same as that. So I know that at least to this point, my calculations, I can be pretty sure I've done it right. And then lastly is the phase shift. So I need to subtract pi over 4. Subtract pi over 4. Subtract pi over 4, subtract pi over 4, subtract pi over 4. So I end up with here then, 0 minus pi over 4 is minus pi over 4. So I'm not starting on the vertical axis anymore. The whole thing is shifted over. Pi over 4 minus pi over 4 is 0. There's where my axis is now if I wanted to write it in. Pi over 2 minus pi over 4 is pi over 4. 3 pi over 4 minus pi over 4 is pi over 2. And pi minus pi over 4 is 3 pi over 4. So those are my 5 marks, and again, just to kind of clean things up, I'm going to erase all the calculations, so go ahead and pause if you still need to write any of these numbers down. So, now we need to draw our basic curve so that we can draw in the secant function. Now we know there was no amplitude change, so it's plus 1 minus 1. But I'm starting over here. I would have started at this point, right there. And then remember what cosine does. It's sort of that V shape, and we're doing cosine as our basic because of related to secant. So from here it would come down to here at 0, then down to pi over 4, up to pi over 2, ending at 3 pi over 4. So if I just drew it in, if I was graphing y is equal to cosine of this guy, that's my graph. Then I'm done. So that's what I'm talking about this practice. If you can do sine, if you can do cosine, you'll be able to do secant or cosecant, because I had to do that to start with. Now is where the next step comes in. Remember, these have the asymptotes. So anywhere that this is hitting the horizontal axis, this is actually going to have a vertical asymptote to it. So at 0 and at pi over 2. Once I have that drawn in, the rest is just drawing a parabola, which is the reflection of the dotted line piece inside of my asymptote areas. So technically, I guess I could stop there. So that is the graph, the red portion. So the curves and the asymptotes, you have to have the asymptotes in there. The red portion drawn on this graph is the graph of y is equal to secant of 2x plus pi over 2. Hope that was clear for you. Again, work those examples, practice as much as you can. Come to class with any questions. Thanks.